All right, good morning. So, sorry I can't be there in class today, but we're going to continue solving with trig by factoring. I'm not going to do all of these here, but just a gentle reminder, like when factoring, a lot of times, like the first move you can look for is like to see if there's a GCF. So this has an x common to both terms. So I can factor out the x and I'm left with 2x minus 1. That's all we can do there. For x squared minus 4, there's no GCF, but it is a difference of 2 squares. So that would be x plus 2 or x minus 2. I would also accept x minus 2 times x plus 2. So again, see if you can try C and D. You might want to rearrange D when you get there to standard form. Look for a GCF and then factor. Here your GCF, what's common to both is that they have y. I really do think that you can do 2A, B, C. I'll post my key to this as well so you can check. So I'm going to bypass that, but I'm going to ask that you do that on your own for a few minutes. And the new material starts here with trying to determine like how to solve an equation. So you have a couple options for factoring. The first option is you could move everything to one side and set it equal to 0. So if I subtract the 1 from both sides, so minus 1, minus 1. And you have to kind of think of sine squared theta as just like a variable. And this is actually factorable. So we can do 2 sine theta plus 1 and 2 sine theta minus 1 equals 0. Because again, if I were to use the double distributive property, that would get me back to 4 sine squared theta minus 1. Okay, so it's like a difference of squares. So it's almost like, let's see here, like 4x squared. So you have to kind of think of like the sine squared theta as your x squared. So this would be 2x plus 1. So same idea. It's just a little trickier with your trig functions thrown in there. Okay. So by zero product property, I'm going to set each of these equal to 0. So 2 sine theta equals plus 1 equals 0, and then 2 sine theta. And let's take it one at a time. So here I'll subtract 1 from both sides. And over here I'll add 1 and then subtract or divide by 2 from both sides. And you have to read these carefully. This wants all real solutions, so not just from 0 to 2 pi. So I'm going to need to see the plus 2 pi k or plus pi k, depending on the situation, where k is an element of the integers. All right, so sine of theta equals negative 1/2, so let's draw that out. And I'll use red for this one. So sine of theta, where's the y-coordinate opposite of this central angle? About 1/2 the length of the opposite of the hypotenuse. So I'm going to put this here. And so to get all the way to here, if the opposite side, if this is negative 1/2, I know it's a 30, 60, 90, x squared 3 or 2x, that's a 30-degree angle. So the reference angle is pi over 6. So one answer could be 7 pi over 6. Or to get around to this one, it would be 11 pi over 6. So I'm going to write that down over here. For sine of theta equals 1/2, notice if you continue a perfectly straight line here and here, we get a special property that this is a perfectly straight line here in yellow, and then here in green is also a perfectly straight line. So for sine of theta equals 1/2, theta would be pi over 6 or 5 pi over 6. And if you watch from pi over 6, which is right here, if you do a 180-degree rotation, you'll get to 7 pi over 6. So these are connected here. So our final answer is going to be theta equals pi over 6. 180 degrees is pi radians. And then if you were to look at your 5 pi over 6, so that's this right here, if you did a 180-degree rotation, you would get to 11 pi over 6. So the second answer would be 5 pi over 6 plus pi k, where k is an element of the integers. If you wanted to, instead of subtracting 1, you could have divided both sides by 4. So you don't have to write this down, but just take a look. It's totally up to you. When you divide both sides by 4, then you can square root both sides. And it might save you just a little bit of time. I just wanted to show you both sine of theta equals plus or minus 1/2. So again, try factoring for the rest of these. This one is actually not factoring. You're just going to solve it like we did yesterday. But then over here, you're going to be doing some factoring. So again, like if there's you're going to ask yourself like what's common? Okay, cool. These both have a sine theta. So 2 sine theta minus 1. Notice the interval is from 0 to 2 pi, so no need for the k, where k is an element of the integers. And you're just going to hit it with zero product property today. All right, so sorry again, I can't be there today. I hope this helps, and I'll see you in class tomorrow.